Maybe at this point it doesn't make much sense whether to look at the title page or not, but except for this might help you think about this. Geometric sequences in series you were probably introduced to in Math 10. You looked at arithmetic sequences in series in Math 10 quite heavily, and you might have just looked at this to see the difference between them. This is a geometric sequence. If it went something like this, 1, 2, 3, 4, 5, or it went 1, 5, 9, 13, 17, that would be an arithmetic sequence. These are arithmetic. This is geometric. I'm not sure if you can right now see what the difference is. What's the difference between those? Let me write them up here. What's the difference between a geometric and an arithmetic sequence? Arithmetic is something like this. 1, 3, 5, 7, 9, 11. Yeah, pretty much exactly, right? One uses addition. In an arithmetic sequence here, you're adding plus 2, plus 2, plus 2, and so on, right? You study that in Math 10 because you look at linear functions. An arithmetic sequence has a connection with, arithmetic sequence is a linear function if you graph it. If you were to graph all those points, right, let me see if I have this open here somewhere. Not that. Whoa. Pause this. Okay, if we put some points on here for an arithmetic sequence, what was the one I just said there? 1, 3, 5, 7, and so on, like that. That's a as you go up here. No, actually, I started at 0. I probably should have started at 1. For sequences in series, you have discrete points here, not this line. But if you do draw a line through there, this is a straight line, right? There. Arithmetic sequences you learn in grade 10 because they are linear functions. Those points all fall on a straight line. If I graph a geometric sequence, and I should point out here that I shouldn't have started at 0. I should have started at 1. The first term in the list. If I was counting these objects here, if these were objects, the first term in the list is 1. The second term is that. The third term is this. The fourth term is that. If I do the same thing for this geometric sequence here, the first term is 1. The second term is 2. Third term is 4. Fourth term is 8. If I back to this. First term is 1. No, that's not what I want. It's good when you're recording this on video, your mistakes you make on this. There's the first term. Second term was 2. The third term was what? 4. The fourth term was 8. That is definitely not a straight line. It's curving up. What's going to happen as I keep going here? Let's change the scale and we can see. What kind of a function is this going to be? Let's do this so we can... What's the next term I need to do there? That was 8, so I need 16. There's that one. Where's the next one here? 32. This is probably good enough. Okay, let's squash it down here a bit. What kind of a function is that? It's not a linear function, that's for sure. It's like this, and it starts to curve up here. It's an exponential function. These are actually, we're doing these together for that reason, that geometric sequences represent exponential functions. Whereas if you have a arithmetic sequence, right? If I was to put points for an arithmetic sequence, like if the first term of something was 10, and then the next one was 15, and this was 20, 25, 30. If arithmetic sequences, straight line functions, linear functions, whereas geometric sequences are exponential functions. We'll make that connection more strong as we go through this. All right. The difference in where you apply this maybe is if we're counting objects, we're going to use sequences and series. Whereas if we're measuring something over a continuous variable like time, time is continuous. You might start at 0 and measure time with a stopwatch or whatever. Whereas if you're counting objects, you have the first object, then the second, then the third. There's no in between. Anyways, let's go back to this page here, up to the top. Geometric sequences, a sequence, I don't know if you want to put something, what a sequence is, some kind of organized, I don't know. For what we're doing, it's an organized list of numbers, but I guess it could be objects or shapes or something like that. A geometric sequence is a sequence that where each term is obtained by multiplying by a common ratio. Or the other way to say it would be a sequence where each pair of consecutive terms have a common ratio. In grade 10, each pair of terms, when you did arithmetic sequences, had a common difference. Let's put some numbers down here. So the one that we just had there, 1, 2, 4, 8, 16, 32. Any pair of terms, these two terms here, 8 divided by 4, what does that give me? 2, right? This pair of terms, 32 divided by 16 is 2, right? All the common difference here is, or not difference, the common ratio is 2 every time. Every pair of terms, you divide any two terms, you get 2. That's what makes it a geometric sequence. Common ratio is this, exactly what I just said there. I kind of explained what common ratio is here as well. If you divide any two terms, you get a common ratio, if it's geometric. Maybe we could put something down here that's not geometric and see why it's not. I'm going to move it up here, though. Let me put something up above here that's not geometric. Maybe 5, 10, 20, 60. If you look at any pair of terms there, what's the ratio between these two terms? Times 2, right? The ratio is 2 there. What's the ratio there? 2. So far it's geometric. What's the ratio here? 3. It's not geometric. That, at that point it's not geometric anymore because it's not the same ratio every single time. Not geometric. Some of the symbols that we're using here that are similar to what you used in grade 10. If you have a sequence like the one we just had there, again, I'm going to rewrite it so we can use it here. 1, 2, 4, 8, 16. For some reason, somebody's decided to call the first term A, and then the second term, term 2, and the third term, term 3, and term 4, term 5. To me, it would make sense to call the first term what? What symbol to use? T1. So you could say T1 or A, up to you. All the formulas that you're going to have on the provincial exam and on formula sheets are going to have A for the first term. But you could call it term 1. Tn is the nth term. If you really want to sound like a mathematician, you say things like the nth term, right? This is the 4th term. This is the 5th term. If you go ... and you say Tn, you don't know what n is, but you can still say this is the nth term. N is, I don't know, number of terms or term number. I don't know why I'm writing it on the right, on the left there, by the way. Number of terms or term number. I am. I could stop now. And R is the common ratio.